Hello, everyone, and welcome to Florida Data Science Academy. I'll be your instructor, Dr. Dylan Sinnickson. And in today's lecture, we're going to be going over subsetting data in R. This is a very common data cleaning practice that data scientists often have to employ. We're going to be going over a variety of different techniques of how to subset data in R. In particular, we're going to be using the subsetting function. We're going to be using the filter function from the dplyr package, and then we're going to be using square brackets. So the data set that we're going to work with today comes from the Our World in Data website that hosts a variety of different great data sets that are helpful for data scientists. We're going to be working with capture fisheries and aquaculture production. So we're going to be using some fisheries examples of how to subset data in R. So let's start off by loading the dplyr package. Then I'm going to set my working directory. And then I'm going to load this capture fisheries and aquaculture.csv file. So we can click on the data frame called DF, and we see that we have 5 different columns. We have an entity, we have a code, we have a year, we have aquaculture production in metric tons, and then we have capture fisheries in metric tons. So it looks like we have our entity involves a country, and then we have a code, and then I think the years and the fisheries examples are self-explanatory. But let's check this code variable. So if I double click on code, we can see that when we try to line things up in alphabetical order, we're starting with Zimbabwe as our last country. But then as we move to the top, it looks like we also have some entities, which I thought that were only going to be countries. It looks like some of them are regions or continents. And then we have a blank country code for rows 60, 61, and so on. So there's actually going to be a variety of different rows that don't have a code because they're not actually countries. So what we're going to have to do is use the subset function to remove those rows that we're not interested in. So what I'm going to do is create an object called countries, and I'm going to set it equal to the subset function, where I'm going to call that data frame, and then I'm going to call data frame code. And that is going to be on that line. And I'm also going to use the not equal syntax. So when you're setting something not equal to something, we're obviously going to use the exclamation point followed by an equal sign. And then if you want to create a blank symbol in R, all you have to do is create the quotations, and we're going to have no space in between these quotations. And hopefully on this line of code, we are going to create an object called countries that's going to be equal to all of the rows in the data frame called DF that have a code variable that's not equal to nothing. So it's always going to have something in that cell. So then we can run line 11 and we can look at countries, and then we can double click on code, and we've successfully removed some of those faulty blank symbols for those continents that were giving us a problem. So let's also work with another something else I want to clean up in this countries object that we just created. If we look at the capture and aquaculture landings, if I double click in that so we can sort it in ascending and a descending order, it looks like we have some rows that are equal to a world variable as our entity, which has extremely high values of aquaculture production and capture fisheries landings. So I thought that when we're going to subset the code by removing the blank cells, that we were only going to get countries, but it looks like we also have a world variable that obviously is not a country. That's going to be a collection of all of the countries on Earth. So we're going to have to remove that world variable as well. So let's rewrite this object called countries, where we're going to use the subset function again, and then we're going to call countries. And now we are going to work with the entity column, and we're going to use the not equals to symbol, and we're going to call world because we want to remove all the rows where our entity is equal to world. And if we run line 12 and we take a look at countries, now if we sort our aquaculture landings in descending order, we no longer have a variable called world as our entity. Now we're sorting the country that has the highest aquaculture production is China. And if we sort by capture fisheries, again, we have China. So we've successfully removed the world cell that was giving us a problem. So that's one way of subsetting our data set for just countries. But let's also, let's say we just wanted to sort for the country, the United States. So let's call an object called the United States, and we can use the subset function. And now we're going to call countries, and then we're going to call countries. We're going to set our entity, and that's going to be, we're going to use the double equal sign because this is a logical statement. We're trying to assess if a certain scenario is either true or false. So we're going to call the cell United States. And then if we run line 15 and we open up this new object called United States, we have an object that looks like we have 59 different observations with 5 variables. And we have all of the fisheries landings for the United States from 1960 to 2018. That's the entire range of our data set, I believe. So that looks great that we've successfully created this object called the United States. So that's some good basic practice using the subset function, but let's also work with the dplyr package, which some people think is a little bit more user-friendly. So let's say I want to, we're going to work with this new object we just created called countries, and then, but we only want the modern years. We don't want anything, we only want to work with the 21st century from the year 2000 and onward. We don't want to work with anything in the 1900s. So let's create a variable, an object called modern. So that's going to be all of the countries where our cells are equal to the year 2000 or greater. So let's call, again, countries, and we can use this pipe function. So if you're not familiar with the dplyr package, when you're piping, using this pipe syntax, so that's going to be a % followed by a greater than symbol, and then another % That just means you're taking an object and you're going to use another function based on that previous object that you just created. So I'm going to take countries, and then I'm going to apply this function called filter. Pretty self-explanatory. Filter is going to be a subsetting type function. And we only want the years that are greater than 1999. So hopefully on lines 21 and 22, we will be taking all of the observations that we have in countries, and then we're going to be removing all of the years that are equal to 1999 or less than 1999. So we'll only have the years 2000 and onward. So when we run lines 21 and 22, we can take a look at modern, and we can filter by year. And it looks like we have successfully removed all of the 1900s values. So we only have years from the year 2000 and to the last year of our data set, which is 2018. So that's a good practice using the filter function. Let's do another example where we want to now subset our data set for only the observations where we have very large numbers of capture fisheries. So we want only the cells that have capture values in metric tons greater than 1 million. So let's create an object called large harvest, and that's going to be set equal to countries. And we're going to use that pipe function. Now we're going to filter by capture. Let's see, we have capture in metric tons. Sorry, my cat is jumping on me right now. But okay, so we have capture greater than, let's see, we're going to have 1 million metric tons. 1, 2, 3, 1, 2, 3. Don't use, I tend to not use commas in our syntax for signifying certain large values. I think that can be certainly problematic. So unfortunately, you might have to get a little bit comfortable when you're working with large numbers, not using commas. So there may be a way of working through that in R, but I tend to not use commas. So we have large harvest, and we can move from lines 25 and 26. And now we can take large harvest, and if we work with our capture fisheries, now we can see that our lowest capture fisheries value is in Iceland in 1975. They had just over 1 million metric tons. And then the largest value we have is in China in 2015, where they had, it looks like, I believe that's going to be 16 million metric tons of capture fisheries. So that's great. Now let's see if we can actually combine both the syntax that we had on lines 21 and 22, as well as lines 25 and 26, where we're going to have the modern countries, and we're also going to have very large values. So let's take large modern. So the new object we're going to create called large modern. It's going to be set equal to countries, where we have we're going to use the filter function, and then we're going to call year. It's going to be greater than 1999. And there we go. Again, going to use this piping syntax for a second line of subsetting, where we're going to call filter again. And then we're going to call capture metric tons, which is greater than, again, 1 million. So, all right. And now if we call large modern, we can take a look. Let's clean up some of these other data sets that we've been working with here in our view window. And we can work with large modern. And now we have our years, again, all greater than the year 2000. And we can look at our capture fisheries, and they're also all greater than the value of 1 million. So now we have filtered by two criteria, where we have the years all of greater than or equal to the year 2000 and very large capture fisheries. So that's great. We've used kind of a combination of two subsetting functions with the pipe syntax from the dplyr package. And now what I'd like to do is actually go back to using the subsetting function, where we're going to apply multiple different criteria. We've already done this with dplyr, but now we're going to use multiple different criteria using that original subset function that we worked with earlier. So let's call this new object. It's going to be called intermediate modern. So this is going to be capture fisheries that are not too big, not too small, but they are going to be all greater than or equal to the value 2000. So let's set this equal to the subset function, where we're going to call the data frame countries, and countries is going to be set equal to year. This is greater than or equal to the value 2000. Again, we're using a little bit of different syntax. Previously, we were just using greater than 2000. Obviously, the criteria of greater than the criteria of greater than 1999 is the same as greater than or equal to 2000. So I'm just giving you a couple different ways of applying syntax in R to get the same result. So let's work with the syntax greater than or equal to 2000, and then we're going to use the AND symbol, which is going to signify multiple different logical operators. So we're going to have a couple different criteria that we're trying to work with here. We're going to have the modern years, and then I'm going to click enter. Again, in R, you can simply click enter, and we're not going to mess up our code that we're working with. It's just a kind of a user-friendly thing we can do. So I'm going to set my countries. Let's see, capture metric tons is less than less than 1 million, and our capture fisheries are greater than 10,000. Okay, so let's work through this. So this is going to be intermediate capture fisheries in the modern era. Okay, so we're going to have this countries variable we've already created. We're going to subset for the years that are greater than or equal to 2000, and the capture fisheries that are less than 1 million, and capture fisheries that are greater than 10,000. So hopefully that will create the object that we're looking for. So if we run, a little bit of a syntax error, always have to close your functions with another parentheses. So again, if you don't successfully close your parentheses, you get a little plus sign. That means it's still trying to calculate something. So if you just put your cursor in the console and click escape, you'll get out of that situation. So if I put my cursor on line 36, I click Control and Enter. Then we look in the, we've created intermediate modern. So this will be this data frame here. And we look in our years, all greater than or equal to 2000, and we can look at our capture fisheries. Lowest value is about 10,000 and Mauritius. And the largest value is Argentina, just under 1 million metric tons in the year 2008. So that has created the object that we were looking for, these intermediate capture fisheries that are all relatively modern. So that's good. We're working with more complicated subsets. We have different multiple criteria that we're working with. Now let's move on to working with square brackets, where we're just gonna, we only want to create a data frame that's the capture fisheries, and we only want to create a data frame that's the aquaculture production. So how are we going to do that? Well, let's first take a look at the names of our countries data frame that we've created. So here are our 5 different columns that we're working with. Obviously, we have our entity, we have our code, our year, we have our aquaculture production in metric tons, and we have our capture fisheries in metric tons. So I want to create a data frame that has just only the aquaculture production and another data frame that only has the capture fisheries. So how are we going to do that using square brackets? Well, first of all, let's create an object. We'll call it capture one, because I think I want to do this 2 ways to show you 2 different ways of subsetting in R. So we can have our capture fisheries, and we have our countries, and then we're going to use square brackets, and then we're going to use a comma. So this means in R, when you're working with square brackets, the left of the comma represents the rows, and then to the right of the comma represents, sorry, my cat is getting in the way again. We have the left of the comma represents rows, and the right of the comma represents columns. So in this data frame, we want all of the rows, but we only want to have certain columns. So what I want to do is keep all of the entities, and I want to also keep all of the years, and I want to keep the variable capture. So I think the code is relatively redundant. We don't need that, and we're not going to use the aquaculture variable either, because that is going to be in its own data set. So if we want to subset only for entity, year, and capture, what we can do is use the concatenate function. So that's the C function. And now I'm going to use you can use the double quotation or the single quotation, it doesn't matter. So I'm going to call entity, and then I'm going to use a comma, and then I'm going to call year, and I'm going to use a comma, and then I'm going to call capture.mt. So hopefully on this line 50, we're going to be subsetting that original data frame called countries, and we're going to be calling all of the rows, but we're only going to be calling the variables that are named entity, year, and capture. So hopefully this new data frame they're going to create has the same amount of rows, but only has 3 variables. So if we look at capture.1, we can see that in our top right-hand portion of our screen, or we can use this stringer, the structure function. Let's take a look at the structure of capture.1, and we can look at the structure of countries. They both have the same amount of observations, which is 11,845, but capture 1 has 3 variables, which are called entity, year, and capture, metric tons, while the countries variable has the same amount of rows, but has 5 different variables. We can also open capture.1, and looks like we have successfully subset that countries variable that we were working with earlier. So I also want to show you a second way of doing this, which is somewhat helpful. So we can call capture.to, and we have our countries, So now I'm not going to call the variables entity, year, and capture by their name. I'm going to call them by their number. So how will I do that? Well, I can use the comma, and then I'm going to use concatenate. So because entity, year, and capture are the variable numbers in countries 1, 3, and 5, all I have to do is actually call 1, 3, 5, and this is hopefully going to create the same exact data frame as using this syntax. Just as a reference, I prefer using this syntax on line 50 because sometimes you can create errors when you're using numbers. Maybe you miscalculated or miscounted the number of variables in your data set, and now you're off. I think it's always best to call variables by their name, but you can also use this syntax. Sometimes it's helpful. So if I create run line 51, we have capture.to. It looks like it has the same number of variables and the same number of rows. But let's use a function to make sure that these are identical data frames. So how do you make sure two data frames are identical? Well, you can use the identical function. So if I call identical and I call capture.1 and I use capture.2, it looks like that these two data frames, we get a true statement, meaning that these two data frames are identical. There are no differences. So yes, it is true that using the syntax on line 50 or using the syntax on line 51 creates the same variables. So it will be a personal preference. If you want to use square brackets to subset variables, I think that using the syntax on 51 is a little bit more appropriate, has less errors when you do that way, but you can use numbers as well. So let's do the same thing for aquaculture. So I'm going to now create, because these are just capture fisheries, let's do the same thing for our aquaculture production. So we have our countries variable, and now we're going to call a comma and use the concatenate function. We're going to call entity, and we're going to call year, and we're going to call aquaculture.mt, metric tons. And now we can look at aquaculture, and looks like we have successfully created that data frame that we were looking for. So now what I'd like to do, let's take a look at aquaculture, and it looks like we have zeros, and then we have some in the thousands and some in the 10,000s, but it does look like if I move down to certain countries like Dominica, they have NAs in their for their aquaculture values. So sometimes NAs will cause you problems when you're trying to calculate certain metrics in R. So you always want to account for those NAs. They can often cause problems. Sometimes you like to keep them, sometimes you like to take them away, sometimes you like to interpolate them. So you kind of create estimates based on other values to create to write over those NAs. But for this example, let's just count how many NAs that we have. So if I use the sum function, and then I use is.na. Is.nas are kind of the go-to function when you're trying to assess if some variable or some cell is equal to an NA value. So I'm going to call is.na, then I'm going to call aquaculture, and now I want to find the NA values, not in all the rows, not in all the columns, but of all the rows within this column called aquaculture.mt. So if I run line 56, it looks like we get a value of 3,017. So when we do, if we just did is.na on the column, we get all trues and falses. So just as a helpful tip in R, trues are equal to the value 1 and false is equal to the value 0. So if you want to count all of the true statements in some type of logical operator, you can just use sum. And when you sum up those values, you get all of you can count, in this example, we can count how many NAs are in our example if we're using some type of logical operator such as an is.na statement. So if I run the sum function with is.na, we can count that there are over 3,000 NA values in our aquaculture data set. So let's say we wanted to remove those NAs. We want to create a data set that's called aquaculture, but we don't want to have any NA statements in it. So let's try a creating an object called node.na, and we'll call it equal to countries, where now we're going to use square brackets again. So if you want to find values that are not equal to NA, we can use that exclamation point, and we can call is.na, and we're going to call countries where we're going to work with the aquaculture MT, and then we can call the comma, which is, so in this syntax, we're calling that original data frame we had called countries, and we want to subset all of the rows where countries, the aquaculture production, is not equal to NA. We want to remove all those NA values, but we want to keep all of the variables and columns in general. So if we click Control and Enter, we can look at node.na, and it looks like we have 8,828. So I'm guessing that if we added 3,000 to that, we'd probably get to that original 11,847 value that we had earlier. So again, we can kind of look through this aquaculture.mt. Looks like my computer is a little glitchy, but I don't see any NAs that we were working with earlier. So I think we should be set in that regard, but let's just have a double check. We can use that sum function, and then we can do is.na, and we can call this new object that we created, node.na, and we can call the $, and we can call aquaculture.mt. So hopefully this will count how many NAs we have in it. I'm hoping that there won't be any. We'll get a value of 0. So indeed, we do get a value of 0, meaning that in this new variable object that we created, node.na, it successfully removes all the NA values because we counted them using this sum function. So that's great. And now we're almost done. We're going to move on to our last example, which is the percent in this in syntax. Technically, it's percent in percent. So that means just if you have, let's say, a certain vector with a variety of different characters, and you want to subset you want to subset a data frame based on some criteria of a value being within another larger vector. You can use this percent in syntax. So let me just use this demonstration. Hopefully it'll make more sense. So if I let's say I want to subset that countries object that we created earlier, but I don't want all the countries. I want only the countries that are in the G8, so kind of the 8 largest economies in the world. That'll be United States, Canada, France, Germany, Italy, Japan, Russia, and the UK. Generally, those are considered the G8. So let's first create a vector called the G8, and that'll be set equal to, actually, it looks like I was noticing that my text is green. That generally means there's some quotation somewhere. Indeed, there was. So I got rid of that quotation. But let's call this G8 vector, and we'll set that equal to the concatenate, where we're going to call the United States, and then we're going to call Canada, and then we're going to call France, and then we're going to call Germany, and then we're going to call Italy. We're going to call a comma. Again, we can successfully click Enter, give ourselves some space, no problems there. We're going to call Japan, Russia, and lastly, the United Kingdom. Okay, great. So if we call G8 vector, let's type out G8 vector. Looks like we have a vector consisting of 8 character elements. ranging from United States, Canada, France, and then we get to the UK. So we've created that vector, but now I want to subset that country's data frame only for the countries that are in the G8 vector that we created. So let's call a new object. This will be a data frame called G8, and that's going to be equal to the subset function, where we're going to call countries, and countries, the entity, we're going to use in. So we can't, again, we use this percent in syntax when we have a greater vector, a variety of different elements that could be used to subset or found. We want to find whether our values are in this larger vector. So we're going to call in, and then we're going to call our G8 vector that we created earlier. So hopefully this only subsets the countries in that variable, in that object called countries, that are within the G8. And if we call G8, now let's take a look at G8. We can look at the entities, and it looks like we have Canada, France, Germany, Italy, Japan, Russia, United Kingdom, United States. So it looks like we've successfully subset for those variables. We can also use a couple different functions just to determine all of the unique values within this new G8 object that we've created. So let's call it unique G8. And we want to look at the unique, let's say the unique entities. So now if we take a look at all of the unique entities in G8, which should be the unique countries, again, we have our 8 G8 countries. So we've successfully subset that original data frame called countries for only our G8 countries. So that's going to conclude our subsetting function, subsetting tutorial. Again, we've worked with our subsetting function. We've worked with the dplyr package, particularly the filter function. We use a couple different logical operators. We've removed NAs through our subsetting analysis, and then we also use the percent in syntax for this G8 example. So that's going to conclude our subsetting tutorial. I hope you learned a lot in this video, and stay tuned for more Florida Data Science Academy videos. Thanks a lot for your time. Bye.